Hi, welcome to solveandgo.com. In this video, I'm going to introduce L'Hopital's rule and do a few easier examples applying L'Hopital's rule. Okay, so L'Hopital's rule is used in, for example, the following scenario. So suppose we were asked to find the limit as x goes to 0 of sine of x over x. So what happens when we plug in x equals 0? This is always a good idea when you're trying to evaluate a limit. Try plugging in the value that x, in this case, is approaching. Well, we get sine of 0 over 0, which is 0 over 0. 0 over 0 is what's called an indeterminate form. What this means, it means that the expression isn't telling us anything about its actual value. Okay, so 0 over 0 came from this expression, but in fact, limits like this could be 0, they could be 1, they could be plus or minus infinity, or any other real number value in between. Okay, so what we can do here is use what's called L'Hopital's rule. So before getting to L'Hopital's rule, let me give you one other example of where this might come up. Suppose you were asked to find the limit as x goes to infinity of e to the power of x divided by x. Again, we see here that the limit as x goes to infinity of e to the x is infinity, and the limit as x goes to infinity of x is also infinity. Okay, so here we get something like infinity over infinity. Okay, this expression isn't exactly precise, but what I mean to say is that the limit of the thing on the top is infinity, and so is the limit of the thing on the bottom. Okay, so this is another indeterminate form. Okay, L'Hopital's rule helps us in these cases. So what it says is the following. It says, if the limit as x goes to a of f of x is the same as g of x, and these are both 0, or they're both plus or minus infinity, okay, plus or minus infinity, then what we can do in evaluating the limit of the quotient is the following. The limit as x goes to a of f of x divided by g of x equals the limit as x approaches a of, well, in this case, L'Hopital's rule tells us we can take the derivative of the top and divide it by the derivative of the bottom, and these limits are equal. Okay. So let's give an example. We'll use the examples we used earlier. So suppose we're asked to find the limit as x goes to 0 of sine of x divided by x. Okay, so again, as we saw, this is an indeterminate form. We get 0 over 0. Okay, so what we can do using L'Hopital's rule is the following. So this is using L'Hopital's rule. Okay, the limit of the top is 0 and the limit of the bottom is 0. So using L'Hopital's rule, this equals the limit as x goes to 0. The derivative of sine is cosine of x, and the derivative of x is 1. Now we can just evaluate the limit by plugging in x equals 0. This is cos of 0, which equals 1. Okay, and what about our second example? Find the limit as x goes to infinity of e to the x divided by x. Okay, so again, we get the indeterminate form here, infinity over infinity. Okay, so L'Hopital's rule applies. The limit of the function on the top equals infinity, and the limit of the function on the bottom is also infinity. So this equals the limit as x goes to infinity of the derivative. So e to the x, its derivative is e to the x divided by 1. Okay, so we get the limit as x goes to infinity of e to the x, which we know is infinity. Okay, so that's L'Hopital's rule and two introductory examples.